Lesson 10.1, we are going to get more into the terminology with circles. What did we talk about on Friday? What's the most important piece of a circle? What makes the circle? The center does. Yep, go ahead and give your circle a center. I'm going to call that center N for now. Okay? On your worksheets, and if you ever look in the textbook or on IXL, it names the circle based off of the center. So in this case, this is circle N. Okay? It always names the circle based off of the center point. Okay, so this is circle N. We started writing equations on Friday of circles. We need a center for that, and what else do we need to write the equation? We need the radius. Yep, go ahead and draw yourself a radius. Add to that, go ahead and draw yourself 2 radius. I'm going to make mine look like that. What do I know about every single radius? It's half the diameter, and what else? They're equal. Every single radius in the circle is equal. With those radius, wherever they meet at the edge of the circle, go ahead and give them points. Name them P and Q. Okay, and then I'm going to put a random point over here. Name that point R. Okay, so like we just said, we know about P and Q that these are going to be the same length. Okay, so if PN was 5, NQ would also be 5. Okay? That's what we talked about last week. Okay, so this lesson, we're going to start talking about different measures. Okay, so if I draw this symbol right here, what does that mean? What's it talking about? It's talking about that angle, right? That angle right there, that is called the central angle. Why do you think it's called the central angle? Because it's an angle at the center of the circle. Okay? On this side, you do not have to draw this, so I don't want you to get a lot of lines in your picture. This side, that is also a central angle. Okay? What do I know about the circle? 360. It's all 360. Okay? Keep that in mind. That's kind of our special number here. So, that's our central angle. Now I'm going to talk about intercepted arcs. Okay? What that means is these angles formed by the radius, they create these arcs. Okay? So, go ahead and draw that. This is called an arc. Okay, from one point from the radius to the other point. Okay, along with this other side, we can also call this an arc. Okay, what's the difference between those 2 arcs that I had drawn there? One's bigger than the other one, obviously, right? What do I know about both of those if I add those arcs together? They add up to 360, okay? So what I'm going to do is I'm going to call this smaller arc, we're going to call that the minor arc. Reason for that is because it is less than 180 degrees. Okay, that's our minor arc. So what do you think I call the other arc? Major arc. Yep, this one's the major arc because it is greater than 180 degrees. Okay. One more thing to talk about in this picture here. If the central angle, if I told you that central angle, PNQ, if I told you that was 115 degrees, what do you think the measure of its arc is? It is the exact same. Yep, the measure of a central angle is the exact same as the measure of its own arc. How can I find the measure of the major arc if I know the minor arc is 115? Exactly. Take 360 minus that 115. Help me out. What's 360 minus 115? 245. So that would be the measure of this major arc out here. If I kind of went backwards, if this major arc right here is 245, what's the measure of its central angle? 245. Exactly. The inside angle measures add up to 360, and the outside arc measures add up to 360. That's why they're the exact same inside to outside. Okay? Along with the minor arc. Okay? Write this note a little bit. Minor arc is labeled with 2 letters. P, Q, with a little arc symbol above it. Okay? Minor arc is labeled with 2 letters, usually. And a major arc is labeled with more than 2. Okay, usually you're going to see 3. So this major arc would be labeled P, R, Q. Okay. Now, with that in mind, go ahead and answer example 1, A and B. All right, on this one, on part A, first of all, what does that little symbol mean right there? That means the arc. Yep. I'm going to ask you this. Does A, the measure of arc xz, does it mean this? Or does it mean this? Means my red one, right? How do I know the difference? Right. This here, that's our minor arc. So we know it's going to be the smaller arc. What is the measure of that arc? 115, because it matches its central angle. Okay. What would the measure be of arc XYZ? How'd you get that? It's the same example. Yep. 360 minus 115 equals 245. I did not mean for those examples to be the exact same. Okay. Now we're going to be talking about arc length. So far, we have talked about arc measure. So again, if this central angle right here was 105 degrees, what would its arc measure be? The same thing, also 105 degrees. That is in degrees. That's in measure. Okay. Arc length, it wants to know the distance from point A to point B. Okay. It wants to know the distance of that, not the angle measure. Okay. Does anyone know how to find the distance around the circle? First of all, what's that called? Circumference. Write that down off to the side of example 4. Circumference. Does anyone know the formula for circumference? Close. That's area. It is something with pi. The circumference formula is 2 pi times the radius. Now, circumference, that means basically the perimeter of the circle. It's the distance around the circle. Okay? So if I wanted to find just a section or a sliver of that circumference, what do you think I have to do with that there? If this gives me the whole thing, how do you think I can find just the chunk? Super close. 105 is a fraction of what compared to the whole thing?
Over 360.
It's a fraction of that 360. So what's going to happen is we're going to take this times that 2 pi r. Because that's going to give us a fraction of the whole circumference. Okay, so off to the side, right by that circumference, go ahead and write arc length. I'm going to abbreviate that for AL. So arc length equals exactly what we just wrote down. N, which is the degrees, so the angle measure, over 360 times the original circumference, 2 pi r. So again, we're taking a fraction of the whole circumference to give us the arc length. Okay, and again, this N, that means the arc measure, okay, or the central angle measure, because they're the same thing. So with this formula, let's go ahead and take a look at example 4. Now, let's look at this one first, and then I'll have you try those. So arc length equals the N divided by 360 times 2 pi r. So plugging in values, what is our N in degrees? 78 over 360 times 2 pi r is 10. Yep. So this is what you type in your calculator. Okay, so you will get decimals on these. Let's stick with rounding to the nearest 10. So to type this in, type 78 divided by 360, hit enter, and then multiply that by 2 times pi times 10. When you're multiplying by pi, please use the pi button. Don't use 3.14. Use the actual pi button provided in your calculator. So on this one, you should get 13.6. So on example 4, A and B, go ahead and find the arc length and then leave room to find the area. So I'm going to put some answer checks up here for you to check your answers. Here are those answers for you to check. Okay, here are the answer checks for the area also on these examples. Okay, along with arc length, we're also going to find area of a specific sector, okay? We're not going to do this example, but when we're finding the area of a sector, it wants to find the area of this whole section of the circle. Okay, so does anyone remember the area formula for a circle? It is this one. That is the area of a circle. That's the whole circle. Go ahead and write that down. Area of a whole circle is pi times radius squared. Okay, so how do you think I find the area of one section of that circle? Multiply it by the ratio. Yep, so the area of a sector equals that ratio, the degrees over 360, times the whole area of the circle, pi r squared. So it is super similar to the arc length formula. So now, using this formula, go ahead and find the area of example 4, A and B.
What's the N? Why do we have to put a triangle
All right.
in a circle?
Why do we have to put a triangle in a circle? I'll tell you. Okay. Triangles are right, especially right triangles, those are always going to be your friend. If you ever see one, you should know exactly what you can do with it. Hint, Pythagorean theorem. Okay? Not going to happen every time, but you guys should be very comfortable with right triangles. They shouldn't scare you at this point. Okay? Looking in this picture, though, it wants us to find the area of the shaded section. What did we just learn to find the area of?
The shape.
Just this, or the whole thing, right? We just learned how to find the area of that whole thing, yes? Let's start with that. Let's find that first. Okay, so that's the A equals N over 360 times pi r squared. Let's find this first. So let's plug in values. What's the degree measure? 90. So 90 over 360 times pi, the radius is 10 squared. If we type that in,
78.5.
I'm going to take your word for it. 78.5?
Yeah.
Cool. So that gives us the area of this whole section of the circle. Is that my answer?
No.
No. What do you think now?
Find the area of just the triangle.
Why?
So you can subtract it and then find that segment.
Right. We also know how to find the area of a triangle. What's the basic formula for area of a triangle?
1/2.
1/2 times base times height. Now, what can be tricky is knowing what the base and the height are. What do you look for in order to know which is which? What'd you say? The angle, right? We want to go based off of this right angle. So what two side lengths are connected to that right angle? 10 and... Why is this also 10? Because it's a radius, right? So this is also 10. So do we have a base and a height? Both 10, right? So we plug in those values. We have 1/2 times the base is 10 and the height is 10. So I heard some of you ended up getting 50. That's for the area of the triangle. So now, how do we find the area of just this little sliver? Just subtract the two, right? So we take 78.5 minus 50. That ends up giving you 28.5. Okay. So I'm going to give you a formula just so you have it to look back on, to remember what we did there. Go ahead and write this off to the side of example 5. So what you ended up doing is you took area of the sector minus the area of the triangle. And then in case you have brain farts later on, remember we did this formula. Minus that. Okay, so that's to find the area, they call it of a segment, okay, but it's just talking about the segment of that shaded region. All right, last example here. It wants to know the area and the perimeter of this shaded area. Okay, so I'm going to find area first. Do I have enough information to find the area of this section?
Oh, no, you have to find it.
Right, does this angle go with this section? No. How do I find the correct angle? 360 minus 260, which is 100. So the angle measure is 100. If the arc measure is 100, what is my central angle? Also 100. Okay, now I can find the area. So we go area equals, tell me. 100 over 360 times pi. Radius is 6 squared. If I type that in, I trust you. 31.4 is what I got.
I got 10 pi.
Should get 31.4.
I got 10.
Remember, this means 6 times 6. So the area of that section is 31.4. So area is done. How do I find perimeter? First of all, what does perimeter mean? The sides, right? The distance around that section. Is the distance from here to here 100? No, why not? Why is the distance not 100?
Because
That's the angle measure. So how do I find the distance?
you do the answer.
I do the arc length, right?
Yeah.
So arc length, I again take 100 over 360 times, what am I multiplying by?
2 pi 6.
2 pi times, not 0, times 6. So 100 divided by 360
10.3.
times 2 times 6 times pi. I got 10.5. So we get 10.5. Is that the whole perimeter? No, that's just this section right here. That's 10.5. Right, what's this side length? Y.
Because it's the same.
Radius is the same. So to get the whole shebang, we take 10.5 plus 6, which is 22.5. That there is your perimeter. All right, looking at number 5, it wants to find, what's that symbol mean again? Arc BC. How many of you found this arc? You did? Okay. Do I need to find that arc or do I need to find this arc? How do I know the difference? What kind of arc is this? It's a minor arc, so we want the minor arc of BC, the smaller one. So how do I find the total arc length, or the arc measure of that? Minor. Yep. 83 plus 51 gives you 134. So this whole thing over here is 134. Okay. This one right here. Is that a major or a minor arc? It's a major. Okay, so it wants me to find A, B, C. There's a couple different ways you can do this. Someone tell me one. I heard 360 minus... Why am I misspelling things? I heard 360 minus 83. Does that work?
Yeah.
Yes. What'd you get for that answer?
277.
277. What's another way you could do that? Is there other ways you could do it? Right. If you took your answer from part 5, you could have done 360 minus 134, which would give you 226. But then what would you have to do to this? You would have to add back that 51 to get you to 277. So there's a couple of different ways you could do that, but if you do it correctly, you should still get to our final answer here. Okay. Part 7, I know they didn't give you a circle, but if it tells you circle P, what does that mean? P is the center, right? So if I draw circle P, P is the center, and it tells us the radius is 8. Okay. And then points Q and R, I'm just going to put them anywhere. and it tells us, I told you this was 60, right? So it tells us the arc of QR is 60, and it wants to know the angle measure of QPR.
60.
It would be also 60, the same. Yep. Awesome. All right, number 8, it wants us to find the area of the sector. Now, it's normally going to tell you that shaded region, okay? So I want to find the area of this whole shaded region. How do I find the area of a sector of a circle?
128 divided by 360
I take the degrees divided by the total times
pi times
the whole area of the circle, which is pi times radius squared. Radius is 10 squared.
111.7.
Yes. Should get 111.7 for your area there. Okay, I for sure want to talk about number 9 and slow down just a little bit. It wants us to find the area of the segment. Now, don't get confused by that. It just wants to know the area of that little sliver. We know how to find the area of this whole thing, yes? Just like we did for number 8. So let's do that first. Let's find the area of the whole thing. So we take, what are my degrees?
90 over 360.
90 over 360 times
Pi squared is
pi 6 squared. Someone help me out. What did you get for that one?
28.26.
So 28.3?
Sure.
Okay. So 28.3 is the area of this whole thing. Okay. What other shape in there do we know how to find the area of? The triangle. Do I know how to find the area of this? No. Okay. But we know how to work with a triangle, especially a right triangle. How do I find the area of a right triangle? 1/2 base times height. How do I know what the base and the height are? What'd you say? Connects to the angle. So this side is 6. What's the other side? Because the radius are all the same. So I'm going to take 1/2 times the base is 6 times the height is 6. I'm going to ask you this. Is the hypotenuse ever going to be a base or a height? No. Nope. So what'd you get for the area of the triangle? It is 18. Okay, so now how do I find the area of the little sector? Yep. Take 28.3 minus 18, which is 10.3.